Hi guys, so in front of me, or in front of you actually, we have a bunch of segments just chilling out over here. There's a method to my madness. I want you to do a little bit of thinking. Now, if you notice, let me go to annotate, and so we're over here. Okay, I don't like that just happened. A little quick erase, get you out of there. Okay, we'll have to leave the rest there, but that's okay. So let's say that I wanted to find out what the length of this segment is. I'm not on a grid, but I do have my x and y coordinates respectively. So typically you guys are all like, well, let's create the right triangle, which I'm totally into, right? So this right here would be my horizontal distance, and this right here would be my vertical distance. Would you all agree with that? I hope so. So if you're looking, and let's say that we don't have a grid in front of us, but we can use the ordered pairs to help us to find out what this distance is, right? If you look over here, I think the best thing to do would be to compare your x coordinates. So if I said to you, how do you get from 2 to 6, it would be how much? You're right, that's right, it would be 4. So this length is equal to 4. And this length over here, that's right, is also equal to 4. How did you get 4, by the way? I hope you said by doing 9 minus 5. And then the same thing over here, you did 6 minus 2 to get 4. Now if I come over here to this one over here, again we're going to do the same thing because we don't have a grid with us. So here's the thing, we're going from -8 to +11, right? Because again, you want to compare those x coordinates with each other. So you're basically going to do, how far is that? And the answer is yes, it's 11 because you're going to do 8 minus a -3 to get 11. To get this height right over here, how much is the height, you guys? Or how tall is this thing, or the vertical distance? I hope you said it was equal to 1 because you did 6 minus 5 equal to 1. Let's do one more before I look at the guy below. So you guys, I want to hit pause. After I put these up, I want you guys to do this one for me. So I'm just going to make this 1, -1. And I'm going to make this one 6, 7. And I think at this point, hit pause and see if you can come up with how to find those lengths. Well, good for you. I hope you did this first. And I hope you said, okay, I'm doing 6 minus 1, which is going to give me 5. So the length of that segment is 5. This right over here is going to be 8 because you did 7 minus a -1, right? Which became 7 plus 1. Are you guys all right with that? Good. Well, what happens when I come down here and I have a pair of ordered pairs that have numbers, but then the other one's variables? What do I do then? Well, we do exactly what we did, but it's not going to be an actual number. Because if you go back over here, again, we're going to compare your x coordinates, right? There's a new color. We're going to compare your x coordinates with your x and 6 respectively. So up here, for me, I did 6 minus 2 to get 4, but I came up with 6 minus 2. So what I would do with that one, if I want to subtract my x coordinates, it would be, you guessed it, x minus 6. Well, if this horizontal distance is x minus 6, what do you think this vertical distance is going to be? You guessed it, it's going to be y minus 4. Awesome. So why don't you guys try this one, or we'll do one more and then I'll have you try it, okay? So let's make this -1, -3, okay? So again, all right. So what's happening is to get these lengths here, we're subtracting our x coordinates and here we're subtracting our y coordinates, right? Here we're subtracting our x coordinates, here we're subtracting our y coordinates. So here we're going to subtract our x coordinates, and if we do that, we get x minus a -1, which is technically, you guessed it, it's x plus 1. My vertical distance over here is going to be y minus. Okay, so in this particular, I don't know what the heck is going on here. Oh, that little thing is, I don't know what that thing is doing. Oh, okay, it's just going to sit there in the middle. Don't mind that. Okay, so here we are. This is the same circle from investigation number 1. So you were asked a couple of things about it. And if you remember, the length of the radius you guys should have found out was 5. So the length of this was equal to 5. And you'll notice this time I put a segment on there somewhere on a random point on a circle, and I called it XY because I don't know what it is. So if you remember, I'm on the hunt for a horizontal length and I'm on the hunt for a vertical length. And if you recall from a moment ago, when you have an ordered pair and then you have a couple of variables, what you do to get those lengths is, remember, you subtract the x coordinates and you subtract the y coordinates respectively. So the orange horizontal length is doing the difference between these two, which is x minus 2 for that one. So the length of this is 5, by the way, and this is x minus 2. And then the vertical length is y minus a negative 3. So this is y minus a negative 3, which is equal to, you guessed it, y plus 3. So this length is going to be y plus 3. And then it says the Pythagorean theorem for this example is going to be, we do a squared plus b squared equals c squared, except this is a squared, this is a, this is b, and then that's c. So therefore, this is going to be x minus 2 squared plus y plus 3 squared is equal to 25, because that's 5 squared. So the equation of the circle is just that. It's exactly the x minus 2 squared plus y plus 3 squared is equal to 25. And that's how you find the equation of the circle when it's not centered at the origin. We'll do another one. So let's say that we have this particular example where your new center is at -1, -1, and I picked a random point x comma y. Okay? It's so annoying when it does that. Sometimes I forget that it's on pen and it gets a little wackadoodle. Okay, so let's say that I want to find out what the equation of this, I want to figure out what the equation of this is. So the first thing I want to find out is what is the radius. So you guys should be able to figure out the radius because you can, it actually hits at a nice spot right over here. I just feel like calling that point xy. So we could just go across 1, 4. So 1, 2, 3, 4, 5. So this is 5, and I'm going up 4. So 4 squared and 5 squared is 25, and 16 is 41. So that's going to be the square root of 41. So the radius is going to be the square root of 41. Okay? Now, let's say that I just randomly wanted to figure out what the equation of the circle is. Okay? And let's say hypothetically, I don't know what my vertical and horizontal distances are, except with respect that this is point x and xy, and this is -1, -1. Okay? So let's say I wanted to find out what it is in general, and I can even do it like someplace else on the circle. But remember, we want to find out what our horizontal distance is, and we want to find out what our vertical distance is. So our horizontal distance, again, is the difference of your x-coordinates. So this is going to be, you guessed it, x minus a -1, which is x plus 1. And then this vertical distance is going to be y minus a -1. You guessed it, which is y plus 1. So now, again, we're going to do the Pythag swag because we have ourselves a right triangle. So therefore, this is going to be x plus 1 squared plus y plus 1 squared is equal to the square root of 41 squared. So if I look at this, this is x plus 1 squared plus y plus 1 squared is equal to 41. And again, this represents the equation of my circle, whose center is at -1, -1. So what I want you to do is I want you to go back and look at the other guy and say, the center was there, and take a look at your equation. And over here, the equation of your circle is -1, -1, and this turned out to be the equation of your circle. I'm going to do one more, and then we're going to go off into the sunset. So I'm just going to randomly make a circle. That's not bad, you guys. Okay. All right. Actually, I don't want to do that. I want to do this. All right. Give me a number. Yeah, I hope you guys said it. Let's go -4. No, let's go -4, 3. Okay. All right. Come on, Shark. -4, 3. And let's pick a point on the circle. And let's call it x, y. And let's say that I told you that the radius is, sure, let's make it 11, okay? And I want the equation of the circle. Okay? All you need to do, folks, please tell me, yes, you're going to make a right triangle. Beautiful. Yes, what is my horizontal distance here, folks? What is my horizontal distance? If you want to pause this and do it and then take a look at it, that would make me so proud. So I hope you said it is x minus -4, which is x plus 4. And then this guy is going to be y minus 3. So therefore, the equation of the circle is going to be x plus 4 squared plus, you guessed it, y minus 3 squared is equal to 11 squared. Beautiful. So that, my friends, takes care of the equation of a circle. So what I'm going to do now is I am going to go back, get out of here. I'm going to go back to this one where we said it was, I don't think this thing is going to let me work. I'll be right back. So if we go back to this problem right over here, we know that the equation of this circle is x plus 1 squared plus y plus 1 squared equals 41, right? So that's the equation of the circle. So now, if you look around the circle, if I said to you, when x is equal to 3, when x equals 3, what does y equal? Okay, so if I look over here, I'm at 1, 2, 3, and that means then, again, 3, it could be 1, 2, 3, 1, 2, 3, 4. It's that point right there, which turns out beautifully. And then 1, 2, 3, 1, 2, 3, 4. Hold on a second. Did I do something wrong here? Oh, when x equals 3, it's this guy right there, and x equals 3 it's that guy right there. I don't know where my head just went. Okay, so 3, when x equals 3, it could be this y coordinate, which turns out to be a lovely number. Oh, turns out to be that it is actually equal to 3, 4, and it hits nice over here at 3, negative 6. Well, let's say we want to find out if that's true algebraically, if that's what we get for our y's, okay? So what I want you guys to do is we're going to go back to this equation and we're going to prove that the two y coordinates we come up with are at 4 and negative 6. So what we're going to do is we're going to plug 3 into the equation and then solve for y. So that means that we're going to have 3 plus 1 squared plus y plus 1 squared is equal to 41. So 3 plus 1 is 4, and 4 squared is 16, plus y plus 1 squared is equal to 41. The last time I checked, 41 minus 16 is equal to 25. So we have y plus 1 squared is equal to 25. So what we're going to do is we're going to take the square root of both sides. So we're going to do the square root of y plus 1 squared is equal to the square root of 25. Now remember, when you take the square root, you come up with how many solutions? That's correct. You come up with 2. But the square root of something squared just becomes the guy inside. So that becomes y plus 1 equals, and then this becomes plus or minus 5, because when you take the square root of something, you should have 2 answers. So what we're going to do is, this is what I like to do, is I create 2 different equations. I'm going to do y plus 1 equals 5, and y plus 1 equals negative 5. So when I solve for those, I'm going to subtract 1 from both sides here, and I get y equals 4. And I'm going to subtract 1 from both sides here, and negative 5 minus 1 is negative 6. So in fact, we showed algebraically that your y coordinates are in fact going to be positive 4 and negative 6. And how cool that we got to see it both ways. Now you guys are to complete all the investigations. I wish you the best of luck.